Hello, everyone, and welcome to our webinar, Accelerate MongoDB to Drive 100x Faster Analytics and AI. My name is Matt Brown, and I'll be your moderator today. One of my main jobs at SingleStore is to organize these webinars, multiple per week, that demo data and AI use cases and new tools and technologies. It's a really fun job. And if you're interested in that type of topic, we've got several great sessions that are coming up soon. So if you take a look at this calendar, you see tomorrow, the 18th, we've got Kafka Unleashed, powering real-time AI with streaming data. Next week, we've got hands-on with the new Vercel AI SDK, which has generative UI capabilities. It generates user interfaces on the fly. It's really, really cool. And then after that, we've got build AI apps and agents in minutes with Phi data. So if any of these topics are interesting to you, please RSVP right now. Hopefully I'll see you in a future session. You can take a photo or a screenshot of these QR codes that you see on your screen, which will take you to the RSVP page for each. I'll put those in the chat, those short links in the chat in a minute as well. So you can just click to register. Heads up, I'm going to preempt the questions. We are working on auto registration functionality. There's a lot of people that want to register for everything with one click. So we are working on that. It's not quite ready yet, but stay tuned for that future capability. Okay, back to today's topic. We would love for you to participate in the discussion throughout the session. There's a Zoom Q&A button at the bottom of your console. We will be monitoring that through the session. We've got experts that are staffing that Q&A to be able to digitally answer your questions as they come in. We also have a live panelist Q&A that we'll do at the end of the session. One note, we're only going to be answering non-anonymous questions. So if you logged in anonymously, just take a minute, log out, log back in, include your name and email address. We love being able to follow up with you. And sometimes when we get a ton of questions, we have to follow up by email. We will try to answer as many of the questions that come in today. Hopefully we'll get to them all, but we might have to email follow you. And finally, we'd love for you to try out the technology that we're going to be showing today. In fact, anyone who tries it today will be entered for a chance to win either new Apple AirPods Pro, the latest version, or the new Meta Ray-Ban smart glasses. Very cool. It's going to be your choice if you're the winner. All you need to do to participate is visit that link or that QR code that's on your screen. I'll put that in the chat in a minute as well. We have a very easy free shared tier. Super easy to sign up. So if you've got an account, just log in to that link that's on your screen. If you're already a customer, great, just log in. You will be eligible. If you're not, if you're new to SingleStore, just create an account in like 30 seconds. It's never been easier to sign up for that free shared tier. Let me introduce our speakers. Vijay, Senior Director of Product Marketing, Manish, Principal Product Manager, and Spandana, Product Manager. Welcome to our panelists. Welcome to our audience. Vijay, I think you have the floor first.
Awesome. Thank you, Matt. Good morning, good afternoon, good evening, everyone, depending on where you're joining from. As Matt mentioned, my name is Vijay Raja, and very excited to be here today with my colleagues, Manish and Spandana, to talk a little bit more about accelerating analytics for your MongoDB applications. So let's talk a little bit more about what we are going to be covering today. So today, as part of today's webinar, what we'll do is I'll kick things off with talk a little bit about challenges with respect to powering analytics or aggregations on JSON data. Okay, we'll introduce SingleStore Kai, why we built it, and provide a quick overview. We'll talk about some of the key capabilities of Kai and showcase some benchmarks, performance benchmarks, and TCO analysis as well. And then Manish is going to talk a little bit about some of the key use cases, how customers are powering their applications using Kai. We'll talk about deployment model, how do you deploy this today, and how it works under the covers. And last but not the least, the best part, Spandana is going to show all of this in action in a very engaging demo on how to get started, and she'll actually show you an app that's functioning on Kai today. Okay, and as Matt mentioned, once we do all this, we'll hopefully have enough time to do some Q&A towards the end as well. Okay, with that, let's jump in. So, as you know, JSON is one of the most common data formats, and it's powering diverse use cases across different verticals, right? So a lot of the financial data or trading data is born as JSON. A lot of the IoT or machine data or log data is generated in a JSON format. Marketing analytics, a lot of the MarTech tools out there, MarTech customers and MarTech organizations, they generate data in a JSON format. The sentiment analysis, a social media sentiment analysis, like Twitter streams are born as JSON, right? And lately I learned like the telco CDR data is also, lots of that is in JSON format as well. So there is a wide variety of use cases that JSON powers today. And it's relevant across multiple different industries, powering diverse use cases, be it real time, be it batch, lot of applications emerging that is using JSON as the underlying data structure. Now, if you have JSON, any customer that has JSON, guess what? They're probably using MongoDB to store it and process it, right? I know a number of you who's joined today, the participants here, most of you, a lot of you are at least using MongoDB to power your applications, right? And it's an amazing database. It's a great database, and they've made it really, really easy for developers to get started and to build applications on. Okay, so if you have JSON data, chances are that you're using Mongo to process and store the data. But the challenge, one of the critical challenges with MongoDB is Mongo is a document database. It's not built for analytics, right? It's a document database. It's built from the ground up as an operational database or as a transactional engine. It's not architected for analytics. It's not architected to do aggregations, joins, or any kind of analytics. But the challenge, though, is a lot of the applications that we talked about earlier, it requires analytics to be served through the application. A lot of these are interactive applications where users are interacting with the application and needs analytics served through the application. And if you're going to ask complex queries or aggregations from Mongo, it's going to struggle, right? Because again, as I mentioned, it's not built for analytics. Especially it can't power anything around real-time analytics or interactive analytics that you're trying to serve through an application. And usually what ends up happening is you typically require an external solution outside of Mongo to power those aggregations or analytics for your application. Okay. So how does this typically manifest itself? Typically what happens is we have seen a couple of customer scenarios. Scenario one, oh, hey, I can't, my analytics in my application is struggling. So the first scenario is a lot of customers, what they try to do is, let me just beef up my Mongo cluster that I have, right? Let me throw in a lot more compute and make the cluster big enough, increase the size of the Mongo cluster so that I can now handle some of these analytical aggregations or aggregation kind of queries, right? Challenge there being it's expensive and inefficient. And even still, it lacks performance efficiency because, again, keep in mind, it's not an analytical engine. It does not have a column store, and it's not built kind of to do analytics, right? So usually scenario one ends up being, oh, let me pour in more money, but I'm still not going to get the benefits and impacts from doing that. Scenario two, which we see a lot also is, hey, what typically organizations do is, okay, now I need a separate engine and maybe a relational engine or an analytical engine to serve all the analytics. So let's double click on that, scenario two. So in this case, what typically ends up happening is customers now have to extract the data. Let me try and move the slide. Okay, there you go. Yeah, so in this scenario, what typically ends up happening is customers now have to move the data, extract the data, flatten the data, right? You're still using MongoDB as the operational database, but then you have to extract data, flatten the data, ETL the data, and put that in another relational database or an analytical engine. Maybe a Snowflake, a Rockset, or Elastic. These are all common systems that are being used as an analytical tool to augment Mongo, right? But the thing is, there's a few challenges, right? Obviously, this adds an extra step in the process. You're now flattening the data. You have to do complex data transformations. You have to build data pipelines. You have to manage data pipelines. You have to make sure that data is in sync. You have to now manage a whole other system, right? But more importantly, you cannot use the same MongoDB queries, right? You have to modify the application and you have to rewrite all of your queries so that a relational data engine like a Snowflake or a Rockset can process it, right? And what ends up happening is it adds more latency. It adds more complexity to your architecture. There is additional data movement. And overall, it makes it more costly and cumbersome for you to manage an analytical application, right? Especially critical when you're serving, as I mentioned, when you're serving analytics through your applications, when you have an interactive application, it just becomes a challenge. Again, it's highly complex, your costs are growing, and guess what? Even after doing all this, your application is not interactive enough or can't scale fast enough. Okay. So this is a typical problem that we see all the time. And this is the reason why we build SingleStore Kai. So SingleStore Kai is a MongoDB API, or is an API compatible with MongoDB that helps developers drive up to 100x or sometimes even 1000x faster analytical queries or aggregations for your MongoDB applications, right? So it lets you drive 100x faster analytics or aggregations on JSON. But here's the fun fact though. The best part of this is you can do this with no changes to your MongoDB queries. So absolutely, you absolutely no changes to your queries or applications. You can use the exact same MongoDB queries for analytics, for aggregations, or the exact same MongoDB queries, point it to SingleStore, and it runs 100x faster. No application changes, no data transformations, no query changes, right? That's the beauty of SingleStore Kai. And the reason why we can do this is because as part of SingleStore Kai, we have built a proxy that converts MongoDB queries into SQL that can be efficiently run by SingleStore. And you're actually going to see this in action today during the demo. Okay. So let's double click a little bit on SingleStore Kai. So we talked about this is a MongoDB, this is an API compatible with MongoDB that can drive, 100x faster analytics for your applications, faster aggregations, faster joins, for all of the JSON collections that you have for your applications, right? And again, you can do all of that with zero code changes and zero data transformations. But more importantly, what this lets you do is developers can now continue to use the same MongoDB tools and drivers and frameworks that you're familiar with without modifying your applications, right? So you can still continue to use the same queries. You can use the same tools, drivers, frameworks on the ecosystem, the MongoDB ecosystem, which you love and which you thrive in, right? You can continue to use those and no need to change the applications. But here is where it gets really interesting. If you know about SingleStore is a relational database, right? We are a SQL database. And SingleStore is already MySQL wire protocol compatible, which means anything that runs MySQL runs seamlessly with SingleStore, right? So we are a relational database. We are already MySQL wire protocol compatible. Now we introduce SingleStore Kai, and now we are MongoDB wire protocol compatible as well. So let me say that again. We are MySQL wire protocol compatible already. Now with SingleStore Kai, we are also MongoDB wire protocol compatible. So it is MySQL, which is the SQL world, and also the NoSQL world with MongoDB wire protocol compatibility. So you literally can get the best of both worlds, utilize both SQL and NoSQL or MongoDB for your applications, right? What that enables you to do as a developer is you can now bring the sophistication and the analytical capabilities of SQL together with the simplicity of NoSQL in a single engine, right? That's really what we call kind of the best of both worlds. And you'll actually see this in action in the demo when we go through it as well. So again, that's the beauty of SingleStore Kai. Is like you can now drive faster analytics with zero changes and actually utilize both SQL and NoSQL, to power your applications. And there is no other engine out there that can do that in such seamless fashion. Okay. So today, SingleStore Kai is generally available on all of the clouds, AWS, Azure, and GCP, all three major cloud providers. SingleStore Kai is now available, generally available there. It is also included as part of our free tier. So as part of a free tier, you can just get started for free in like in a couple of minutes. SingleStore Kai is already included at no additional cost, right? So no additional fees or licenses required to start using Kai. Now, we talked about, I throw a few numbers out there saying we are 100x faster, 10x, 100x. What we have done is we have done extensive performance benchmarks, right? Benchmarks to test out how well the queries perform in single store versus on a MongoDB Atlas, right? By the way, all of this is available on our website. So there's a link right below there, and this will be sent to you as well. So there is a blog with the details on this benchmark, on how we did the benchmarking, what is the data type, what are the settings. And you can actually reproduce these results if you want to, if you choose to. Okay. So this performance benchmark, what I'm showing here, is based on a 40 million rows for IoT data for this one. And as you can see, the single store queries are orders of magnitude faster. For some of them, it's like 1,500 times faster compared to MongoDB. In some cases, it's like 34 times, 400 times faster, right? The least one is almost 68 times. By the way, these are not percentages. This is not a 68% improvement. This is 68 times faster compared to MongoDB, right? And the reason these are faster is because of our unique, the advantage that single store has is because of our unique three-tiered architecture, right? So if you know about single store, we are what we call like a unified database. So you can do transactions, analytics, and vectors in a single engine. Now, the way that we make it happen is because of our unique three-tiered architecture. So we have an in-memory row store for fast writes and fast record lookups, but we also have a disk-based column store. This is where the magic happens for analytics. When you want to do fast aggregation, when you want to do complex analytical queries, when you want to do joins and any kind of analytics, the column store becomes a huge performance factor and a huge factor for driving interactive performance for your applications. And then, of course, the third tier in our storage is, of course, the cloud object store, right? So data can seamlessly move between these tiers, delivering ultra-fast performance when you're trying to power these kind of applications. Okay, so this is one benchmark that we did, and as I told you, you can actually go and see that in action on that link there. We also did an external benchmark, which is the ClickBench performance benchmark, right? And this one across 100 million documents, and it runs about 42 different queries. And as you can see, I don't know if you can see here though, the single store queries, single store is really, really fast. Do you see that purple line down at the bottom? That's the query latency for single store. And the green dots are the one for MongoDB Atlas, right? So as you can see, single store is really, really fast for these queries. And it's like orders of magnitude faster when compared to analytical query performance for MongoDB, which is kind of understandable, right? Now, what we did was we also did a price performance comparison. Now, let's say a lot of the customers now I'm saying, you know what? I have a few analytical queries. Let me see how far can I do that with Mongo? So we did some kind of a price performance analysis just to see, hey, if you were to get or even come closer to this kind of a performance, right? Low latency analytical performance for your queries, how much would that cost, or how much would you have to increase your Mongo's cluster by? Based on our analysis, what we saw was that if you have to even remotely come close, still it's not comparable, but even if you have to remotely come closer to this kind of a query performance, you have to beef up your Mongo cluster at least 5 to 7x what you have, right? So based on comparable sizes, the performance is on the left, but if you have to at least come closer to what single store performs, you're talking about 7x the cost, 7 times the cost of what it would cost with single store. Okay, so that's the magic, or that's the value for why low latency analytics matter when it comes to powering your applications. It's not just about performance, it's about the complexity, it's about the cost, and ultimately it's about the user experience that you're trying to power. Okay, so what we did was we took this a step further. We said, let's compare approximate cost. So because we already talked about performance, we know it's about 100x faster. We have benchmarks for all of that. We have customers using that today, which you'll hear more about. But we want to compare from a cost perspective, from a price performance perspective. How does SingleStore Kai compared to other alternatives, right? So we compared three options. Option one was just running these analytical queries on MongoDB, like we saw earlier, right? That's option one. The other option is, as we discussed earlier, you could use MongoDB as the operational database and then use a data warehouse, let's say like a Snowflake or a Redshift, to try and do analytics and do ETL. And let's see how much that costs for some complex analytical queries. And then the last option is using MongoDB with SingleStore Kai as the analytical engine. Okay. As you can see here, and we are running analytical workloads. As you can see here, SingleStore Kai delivers over 50% TCO reduction compared to option two, which is the combination of MongoDB plus a data warehouse like a Snowflake or a Redshift. And it's even more dramatic when it comes to just with MongoDB Atlas. It's an 80% TCO reduction compared to just MongoDB, right? And the reason why we are able to drive, I talked about the architecture a little bit, but for comparing option two to option three, right? The critical aspect there is, remember the fact that there is no cost or efforts involved in ETL because we have an API. There is no data transformation efforts required, right? There is no query changes or application changes that are required. Any of those efforts, data pipelines, managing data pipelines, and data replication, all of that stuff. All of those things go away, and it makes it fast, easy, simple, and efficient. Okay, so 80% lower compared to MongoDB and 50% lower TCO compared to option two. And we have a TCO calculator as well that we'll be happy to share. So up until now, I just gave you the basics of SingleStore Kai, like why we built Kai, what is it, and then and talked about the value proposition, the speeds and feeds, performance benchmarks, and we dug a little bit into the TCO as well. But now let's get into the double click and let's get a little bit more into the details of how do you deploy Kai, what does it look like under the hood, and examples of customers using Kai, and what are some of the use cases. So for that, Manish, if you're ready, I will hand this over to you.
Sure. Thanks, Vijay. And it was a great introduction to what Kai is. So, hey, everyone. I'm Manish. I run the product team for SingleStore Kai. And happy to go a bit more into detail of what Kai, how customers are deploying Kai. At the same time, an example of a customer scenario where we benefited a lot using Kai and what were some of the challenges that the customer had and how we fixed them. Can we go to the next slide, Vijay? Okay, so as Vijay talked about in the last slide, is typically customers start off their applications running on MongoDB, which is on the left-hand side of the picture that you see. That's a common pattern. Customers are using it. It's heavily used, especially with all the proliferation of JSON data. This is a common pattern that has emerged. However, when they have to set up analytics on top of their data, they typically augment that with a SQL-based solution, whether it's Snowflake, Rockset, or other solutions. What we think Kai provides as a differentiated capability is we first provide a zero ETL solution, which you see as a CDC replicate here. This helps you move your data from MongoDB to SingleStore with a simple SQL commands and no expensive ETL tool and management of the ETL tool involved. This moves all your data from MongoDB into SingleStore as is. You can add some transformation if you want, but this tool essentially just moves the data as is, stores it in SingleStore. The application, through a simple connection string, which we will show in the demo, can connect to SingleStore and use the same application code, zero code change, to talk to SingleStore DB as if it's a Mongo database. However, with 100x or at times 1000x faster analytical performance. From what we have seen from customers, we have also seen customers eventually completely moving off of MongoDB and powering their OLTP as well as analytical needs just by SingleStore DB. And that's the beauty of SingleStore Kai, where you start off by augmentation and you can move towards a consolidation if that's the need of the application. So can we go to the next slide, Vijay? So what's the underlying infrastructure of how Kai looks for the customer? So the same Mongo shell and the Mongo tool that you are familiar with uh, can be used to talk to SingleStore DB. SingleStore Kai sits as a proxy in between your database and the application. It's a simple connection string that customers can connect to. It reads the incoming Mongo application queries, converts them into SQL, which you can actually see as a part of a described capability from the engine, and returns the data back to the application. For a customer, this translation is transparent. All they all they need to do is talk to a connection endpoint. They can do that over a regular internet-based endpoint or a private link. All these security capabilities are part of the offering itself. And this just makes it super easy for customers to come and start playing with SingleStore. You can, as Vijay mentioned, you can leverage the free tier, which is the easiest way to get started. And we'll show that in the demo, that how SingleStore's Kai free tier gets you started in like a few seconds, whereas like compared to the industry solutions, and how you can have a more dedicated deployment for your mission critical application needs. And we'll show more of these use cases in the demo in subsequent slides. Can we go to the next slide, Vidya? So let's talk about an example of a customer who was facing problem of using MongoDB with SingleStore. This is a financial services application. They have an application stack which uses SingleStore and MongoDB to process loan application. And this is a complex process because they now need to move the data between SingleStore and MongoDB and back to SingleStore because they have analytical needs, which is powered by SingleStore. It was complex to manage this application stack, primarily because you had a SQL, NoSQL, complex ETL jobs that keep moving data back and forth. And this just added to the complexity of the end-to-end application. And more importantly, because they had to run aggregates and joins, that couldn't be done on MongoDB. They had to move the data back to SingleStore because SingleStore is good at that. And that just added more complexity and the lack of an ability to meet those application requirements just on MongoDB. The solution proposed is to leverage SingleStore Kai and use both the Mongo as well as the SQL API because SingleStore as a SQL database continues to support SQL API. SingleStore Kai just makes it easy to run Mongo queries on top of SingleStore. So this eventually led to a simplification of the architecture by removing the dependency on MongoDB and by consolidating all of that into a single store database and powering your both Mongo and SQL needs to that one database. Finally, because of the zero ETL solution, the data movement aspect was simplified in a tremendous way that helped in the migration journey for the customer. And they are able to achieve 110K queries per month. This is part of their application requirement. However, the single store concurrency is so high that they are able to now power more application needs that they were unable to process in the previous setup that they had. Can we go to the next one? Okay, so where do we see the common use cases? We looked at the deployment, we looked at the customer scenario. Where do we see Kai fitting in best in your application stack? So we see that there are three types of application where Kai is able to make a big impact for a customer. The first one, which is the obvious one, I think it's the augmentation of Mongo application, which needs interactive analytics. As we described in the previous slides, MongoDB is not built for analytical needs. And the moment you need it, you need to move it to either an analytical system and rewrite the application for a SQL interface. In those scenarios, you can simply leverage SingleStore Kai to augment your MongoDB with a zero ETL solution and power your application needs directly by querying SingleStore DB. The second one is where TCO and perf are requirements for the customers. And that goes back to the example of the financial institute. TCO was one of the big reasons why they wanted to look at options beyond MongoDB. More importantly, in the price comparison that we showed in the previous slide, we provide almost 7x improvements over a vanilla MongoDB and at least 50% improvement versus a Mongo plus another data warehouse versus Mongo plus SingleStore Kai. So certainly price performance plays a key role if that's one of the goals that you want to solve. Finally, and we will show that in the demo as well, is with SingleStore Kai, you can power new application patterns that were previously not solvable with just MongoDB. We would want to show that in a demo with Kai and our deep integration with notebooks, GenAI vector use cases and hybrid search use cases, so the new vector capabilities of SingleStore, and how SingleStore Kai can be leveraged along with the SQL capabilities of the SingleStore database engine to power these new use case, which which is actually really hard to solve in just MongoDB or even with the combination of a MongoDB plus another warehouse. And we'll see all of that in action. Uh, I think Vijay and I have covered a lot of detail around why and how to why to use it, how to use it, and what is the details. I think the next part I would want to hand it over to Spandana to go over the demo to put all of this into action and show how customers can really power their new application requirements with SingleStore Kai. Over to you, Spandana.
Yeah. Thanks, Manish and Vijay, for setting the stage and discussing the power of SingleStore Kai. And now it's the time to get it into action and see how it all works. Share my screen. So what we would do is initially we'll see how to get started. So we have heard that free tier is the way to go. With few simple steps and no additional setup, you can start working on your applications. So we'll see how to get started, and then we'll see a live performance comparison on a real life application that is currently built on MongoDB. And we'll also see how we can build new functionalities on top of MongoDB application that wouldn't have been possible just with MongoDB. So let's get started. So getting started is just simple. You can go to our website and click on try new. And yeah, once you're done with your email verification, you would land into the portal where you can see that this is a place where you can look at your compute and storage resources, and you can run queries and yeah, have all the management and management required setup directly from here with respect to users and API keys, etc. So I would go and start with a free workspace. So workspace is nothing but the one that holds your data and also provides you the compute to query the data. So I would go with the starter workspace, which is a free workspace. And you can see that you would get 1 GB of compressed data storage. And here it's 1 GB of compressed data. So SingleStore is really good at data compression. So your data can almost go up to 10 GB, which comes up to 1 GB in compression. And yeah, simply go and create the starter workspace, and there you are, no further steps. And your database is already pre-provisioned for you, and you can start loading data and running queries on top of it. So here, how do I connect? If you have some client applications that are already built, you can take up the connection strings from here. Or the best part is you have options available directly in the cloud portal to interact with your database without any external client installation. So in starter workspace, we have both SQL and Mongo API enabled. So Kai is ready to work. And here you can see that I connected to the starter workspace. And this is a place that you might be familiar with, like a Mongosh or a Compass, right? So this is a Mongo shell that is directly integrated into the portal. So you can see that I'm connected to the starter workspace, and you can start directly writing queries like in Mongo API, of course. So you can just say db.insert. And this would insert a document. So it would create a collection called foo, and this particular document would be inserted into it. You can do multiple advanced use cases, like, so there are certain tutorials to help you run some sample application-based queries. So here, this particular tutorial talks about and collection called inventory, which has multiple products in it. So let's just quickly run this. See, so this step is about loading the data. So there are almost 5 documents loaded. So you can do all these options like finding, so search. You can do updates. You can do even aggregation pipelines. So this is an aggregation pipeline where the objects are aggregated and the total quantity is summed up. So yeah, this is how easy it is to get started. And actually, even other industry solutions are, even Mongo Atlas takes at least 5 minutes for you to get started with their free tier. And there is no option like this for directly working from the cloud portal. You need to have an external client installed. But in SingleStore, you can get started immediately and run the familiar Mongo queries that you already know and get started with your application development. Now let's see a real life application that is built on MongoDB and what is the general problem that it suffers with and how SingleStore can power it up. So for that, I would show you an e-commerce application that is currently running on MongoDB, and it has around 2.5 million documents of orders. So it's an e-commerce app, right? So there would be products and orders. So around 2.5 million documents are already pre-created. And so we would see how the experience is if it just runs on MongoDB. So yeah, this is the application. So you can see that it's a store that sells shoes, and you can browse through the product catalog, look at the product and rate the product or add the product to your cart and make a purchase. So you can see that like any modern day application, be it gaming, MarTech, ad tech. So an application, modern day applications have both components involved. So they demand both transactional and analytical abilities from the database. So if you see the products I viewed, I clicked on transact. So this is an example of transactional query. But if you see, once I clicked on it, there is a feature where it shows how popular the product is over the 90 days, or the last 90 days. So this is an example of an aggregate query. And you can see the total ratings that have been given to this product. So this is also a summation, which is an aggregation. You can also see that this trending now section is populated based on the orders and the past purchases of the customers. So all these require both transactional and analytical capabilities. And that's where MongoDB kind of falls short. Let me reload this page. So you can see that this is not the interactive experience you would want for your users, right? We can see this in more detail in the analytics tab. So this is basically an analytics dashboard that can be useful for, let's say, the store owners or operators to know the trends of purchases. And currently, this app runs on Mongo M40, and there are around 2.7 million orders placed on this application on 10,000 shoes. And these are some sample 3 products, sample 3 queries that are running, analytical queries or aggregation queries that are running on MongoDB. You can see that they're constantly taking forever. And this is definitely not an interactive experience even for the admins, because they wouldn't be able to change the parameters to see what are the top products in the last month versus last year. So all this requires interactive ability and fast analytical performance, right? So that's where you can get SingleStore Kai into the picture. And it's quite easy. So we have seen that there is a 0 ETL capability and also 0 code changes required because Kai is Mongo API compatible. So the same queries would work with Kai as well. So let me get my workspace. So for this application, as the purpose is to look at the performance gain, I would go with the dedicated workspace rather than the free trial. So in the free tier, the compute is shared. So for you to run your production workloads, you would want to move to a standard workspace. And even for a standard workspace, so when you create the standard workspace, you would be awarded 600 credits initially for you to try and explore all the powerful capabilities. So I've already provisioned a standard workspace. I can directly go and get the connection string, because it's an external application that I want to connect to this app, so connect to this database. So I get the connection string and I put it here. So I have to replace the password, which I created before. And that's it. So what this app internally is doing is, okay. Let me reset the password, I think. And get back to my connection string. Yeah, it's easy to reset your password and go ahead with the connection string. So yes, so you can see that the zero ETL has already been powered, and you can see the orders and products and ratings that have been captured from MongoDB. So you can see that MongoDB has this particular database with all the collections, and SingleStore is now ready with the same database for you. And this CDC is not just one snapshot load. It's not just about one time migrating the data. This CDC capability also keeps both the data stores in sync. So let's say, so let me go back and see the orders number. So currently it's around 266, right? Let me place an order. And so it's 266. So as expected, Mongo is taking time even to find the total number of orders. Let's say I place an order. Yeah, so now the orders count would become 267 on MongoDB, and the same got replicated to SingleStore as well. So the CDC that we have set up, the connection, always keeps the data stores in sync, and there is not much steps that you have to do. So in this particular example, app kind of ran the couple of steps required. In case if you want to set up the CDC migration or replication from your own MongoDB, you can just follow this documentation where you just need to run 2 commands on your Mongo client or Kai shell. You just need to create a connection specifying the Mongo URL, and then select the collections that you want to replicate from Mongo. Great. So now that I have the data populated in both, so data present in both the data stores, I can see that SingleStore already has given me results with very short amount of time, and where MongoDB is taking still loading. So from our experience, this takes around a minute. And here, one thing I would like to note is if you run this query again on SingleStore, it would take much lesser time than, let's say, 4.5 seconds, because all the queries that get executed are stored in plan cache. And once the same query gets executed again, it would be optimized. It wouldn't take the same amount of time. It would take even lesser time. So there are multiple such optimizations built into the storage and compute of SingleStore. That is like column store and 3-tier storage architecture, which Vijay has touched upon. So there are innumerable and innovative approaches built into SingleStore database engine that is able to power such unbelievable performance.
So Spandana, this is interesting. So you as a admin, let's say I want to understand what are the top products, and I'm still waiting. It's been over 60 seconds, right? And if you're powering this app in MongoDB, it's still not, that aggregation query still hasn't come through, right? As opposed to less than 5 seconds with SingleStore, right?
Yes, yes. I'm just wondering, it already hit up its maximum just to run a simple
Did you get a
query.
timeout?
Yeah, I think CPU is already at 100%. That's why it's even taking a longer time. Yeah.
Wow. Okay.
Yeah, so it's just
what was the second
about
query? The first one was get top products. What was the second query again?
Yeah, so trending products here, you can give parameters like I want to get the products that are trending in the last 1 week. You can even get it more complex by adding trending products in this particular region. So in this particular region. So all these are the different filters and different joins and aggregations that you can do. Yes. So now I will let this app run in the background. Maybe once we discuss the AI capabilities too, we can revisit back and see if Mongo has actually finished executing this query. Cool. So yeah, so everyone is talking about Gen AI and AI-powered use cases, right? And it's finding applications in all the different sectors and different kinds of applications, both consumer-facing, SaaS apps. So we will see how we can get started with a sample idea in our mind and how we can get it into prototype it and get it into production with the tools that are there in SingleStore portal. So for that, I would be going to the notebooks. So the notebooks is a capability that is present in SingleStore portal. So it would be familiar to you if you have used Jupyter environment. So yeah, this is where you can collaborate with your team, quickly prototype your ideas, and you can use both SQL and Python to get your ideas to life. So what I would want to do as a first step is, so in my app, I would want users to search for the products that they want with just say natural language. Like let's say instead of searching for Hustle or Swift, users could directly search for, I want running shoes, or I want shoes that work on rough terrains. So all these are natural language queries, right? That users would be most comfortable in searching for. I would want to implement that AI-based search into my product. So how I would do that? For that, as you might be familiar, we need to get the embeddings or vectors pre-created for all these different products. And once we have the embeddings ready, we take the user's query, get the embedding for the user's query, and find the nearest match. And there are many vector algorithms like HNSW and IVFPQ, which help you find the nearest products that are closest to the user's search. So for this purpose, for this demo, I have already created the embeddings, and they are stored in, they are stored along with the products. So products is the collection that has general information like what's the product name, product description. So I have now an additional field on top of products, which stores the vectors. I would directly go and get the required libraries installed, and I have already preloaded. So if you want to run this notebook by yourself, you can go through these steps. So what are these steps doing? So I have actually preloaded this data into Mongo Atlas first, and I'm setting up this CDC link so that all the data in MongoDB is replicated to SingleStore. So the data is already replicated, and I already created a vector index on this data. So I have used HNSW type of vector index. So in SingleStore, this is an advantage. You can have, configure many parameters according to your workload. So you can choose the type of index, you can choose the distance metrics, and multiple other fine-tuning parameters that are applicable to that particular index. And yeah, I would then go and get my user query. So in this particular example, I have this user query who is searching for hiking shoes, and I would generate this embedding for this particular user query. I've already generated using OpenAI, so I would directly use this query vector. And this is the simple vector search that almost all the vector databases would provide you. let me see. I think I have, okay. I have to reload this notebook. Just give me a moment.
And Spandana, the notebooks is going to be shared with all of the audience
yes,
here, right?
Yes.
They'll have access to this notebook. Okay.
So the notebook has been idle for some time, so I kind of lost connection to the database. Let me get back. I have the data already loaded. I have the vector index already created, and also the query vector. So this is a simple vector search. Tough luck. Okay, maybe I didn't select the database. So I was able to perform the simple vector search, and yeah, so these are the 3 products because I have asked for top 3 matching products for this particular user query. I can see that the vector search has returned venture, stride, and track, and because these kind of match the user's query, hiking, provide. So this one talks about jogging shoe. This one is about off-road running. So here, as you know, the beauty of vector search is you need not specify the exact keyword like text-based search. You can get to search with the meaning of the user's intent. Now, but this is a sample vector search that is present in most of the vector databases. But generally, vector search is not useful when done in isolation, right? You need to enrich that vector search with multiple other parameters that makes the user experience even more powerful. So now you are showing products that are useful for users' query. But as a user, I would want to know multiple other things about that product, like how popular is the product or how many sales that have happened on that product in the last 1 week, or I want to know the products that are popular in my region. So there are multiple parameters that you need to consider when you are showcasing the top 3 product recommendation based on your user query. So in this particular query, I have taken one simple example where I want to enrich this result from the vector search along with the total sales. So I just wrote a simple aggregation query where the results of the vector search are sent into an aggregation pipeline, and I'm joining the products with the orders collection and summing up the total sales. You can see that the 3 products are now sent back to your application along with the sales information, which are calculated on the fly. And naturally, I would want to go with these products which have more sales than, let's say, the first product. And so this is a simple application of a hybrid search or a contextual search experience where you would want to provide user results that are specific to their context and their natural preferences. I would just
Spandana,
yes.
hey, I just wanted to point out we have about 5 minutes left.
Yes, yes.
So
And this is the last
anything
cell.
we're able to. Okay,
This
thanks.
is the last cell. Yeah. So I just take this query and now run it across SingleStore and Mongo to see how it differs. As we have seen, joins and aggregations are already slow in MongoDB, so the result wouldn't be surprising. So what this cell does is it runs this particular query 5 times in a loop, and that's where you see the performance difference. So SingleStore is the red one where it takes less than a second, and yeah, here itself you can see that there is a 10x lag when SingleStore is pitted against Mongo. And as the aggregation becomes more complex, you can see a huge performance difference. So this is just a simple experience that I built on my existing app, and you can extend it to many other use cases with the vector and Gen AI capabilities that are available with SingleStore and now with Kai. Yeah, thank you, Matt.
Of course, yes. And rest assured, everyone, we will try to answer all questions via email. I'm going to jump right in. Manish, I know there were some questions about compatibility with MongoDB. Can you talk about that for a second?
Sure, Matt. So with SingleStore Kai, it's a proxy with an API support for MongoDB, and with what we launched in general availability, we are more than 80% compatible with the Mongo APIs, which is more than any other competition that we see in the proxy layer. And that makes us a bit different. And we are extending the envelope of how much API coverage we will have in the next few months, where we intend to get to close to 90% from a Mongo API perspective.
Awesome. VJ, I'll give you this one next. Is this augmentation? Can you replace MongoDB for these applications?
So yeah, so a lot of customers, what we have seen is they start with an augmentation just to, because they have an existing Mongo as the operational database. They use SingleStore to augment their MongoDB to power like lightning fast analytics or interactive applications, right? But we have also had customers who started the augmentation and they're like, you know what? I don't need this additional Mongo. SingleStore also has operational capabilities and performance compatible with MongoDB. So why do I need to spend double the money? So we have even had customers move their entire workloads from MongoDB into SingleStore as well. So you can start with augmentation, or we have also had a lot of customers who have done complete replacements of Mongo as well.
And just to add to that, Matt, SingleStore now supports native JSON, which is the Mongo data type as well. So I think that's why going back to the compatibility part, because we offer a full compatibility here with almost more than 80% API coverage, customers have looked at us from augmentation as an entry point, replacement as an exit strategy.
Awesome. Maybe one or two more before we announce the raffle winner. Spandana, I'll give this one to you. Is SingleStore's vector capabilities available for SingleStore Kai as well?
Yes. So as you have seen in the notebook, you can directly use SingleStore's vector capabilities through Kai API. So you can use your existing Mongo clients to run the vector search, creation of the vector index, and also running vector queries directly from your Mongo applications. And the best part is, in addition to what Mongo provides, which is a simple vector search, ANN-based vector search with the pre-created algorithm, in SingleStore, you have the ability to choose the vector search algorithm too, and you can tune it based on your workload. Let's say you want more recall, like high precision with you're not so much concerned about the time it takes to run the query. So there you have options to tune it. Let's say you want faster performance with less recall. There is an option for that too. So it gives more flexibility and power.
Awesome. Jason, I'm going to give this one to you. I've seen it come in a couple times, various versions of it. The question is basically like, this is amazing. How is this so fast? Can you explain how you did this basically?
Yeah, so Kai builds on some of the fundamental technologies in SingleStore around the universal storage format of the tables to be for most of what makes it so fast, where when data gets inserted into SingleStore, there's like an in-memory segment that allows for very fast inserts. Inserts are generally just a couple milliseconds. And then as the inserts come in batches, those are converted to a columnar storage format. And in the vast bulk of the data, then there'll be a little bit of data in the row store format in the in-memory segment, and then most of the data will be in this columnar format. And the benefits of a columnar format are a bunch of things. It gets really great compression of the data because often you can compress the same type of values together much more effectively than you can do it just a row at a time. And it also allows for fast algorithms for searching and aggregation within a column. Like if you want to sum up some values or find documents matching a value, we've implemented those algorithms using some advanced vector instructions on the CPUs that we use in our managed service. And it allows for some really fast operations. As you've seen, when it's fast, it's like really, really fast, and it's fun to see. And you can reach that speed for a lot of the common operations performed in Mongo queries.
Awesome. Of course, all the questions coming in right in the last minute. I've just put into the chat, email us at hello@singlestore.com, mention this webinar title in the subject, Or if you just want to talk with one of our solutions engineers, I've also put a calendar link to their calendar. So you can just click that and book time with them to chat about your use case. I see tons of questions. Again, we'll try to follow up with you via email, but I also want to announce that raffle winner. Actually, one thing before I do that, I'll put it in the chat. We've got several more sessions coming up. The Kafka Unleashed tomorrow, Vercel AI SDK the week after, and then building AI apps and agents in minutes with Phi data. I just put those links into the chat one more time. RSVP, hopefully we'll see you there. The announcement you've been waiting for. Today's raffle winner is Aswathi Bai, Senior Software Engineer at Lowe's in Raleigh, Durham. Congrats. Thank you for joining. If that's not you, don't give up. We're going to announce one more raffle winner today. It's going to be, again, your choice, either the Meta Ray-Bans or the AirPods Pro. All you need to do is actually try this out. Log in, try it out. I'm going to put that raffle link in the chat one more time. And then, yeah, give it a shot. We're gonna send out that notebook that Spandana was walking through. So check your email. It'll be in your inbox in about an hour or two. Thank you so much for our awesome team of panelists and presenters. Thank you to our audience for joining us. We will follow up with you and hope to see you at a future session. Thanks, everyone.
Thanks a lot.
Bye-bye.
Thanks.